The first thing I'm going to say is this is a 200-level session. And what that means is that I am going to try to make this session very accessible to folks who are just getting started. So I'm going to try to cover a lot. I'm going to try to help show you what branching can do for you and why you would want to do it. But I am going to try to stay at that 200 level, because I really want this to be accessible to everyone. So if this is news to you and you're like, oh, I was hoping it was going to be more advanced, it's OK. I am not offended if you're like, oh, I want to see another session, right? So I like to mention the level of the talk at the beginning, because I know sometimes you don't know exactly how advanced a session is going to be. I do know, however, that you've seen this slide a lot over the last few days. And you've seen this slide, too. It's an awesome slide, but you've heard it so many times. So we're going straight to here. My name is Kendra. I am a DevOps advocate. I used to be called an evangelist, but now I have a kinder, gentler title. I'm called an advocate. And what that means is that I get to think about and talk with people and test out and figure out different ways that people can do DevOps. And by DevOps, what I'm really talking about is how can we deliver value to our customers faster? If people in your organization are a little allergic to the word DevOps, that's fine. We don't have to use the word DevOps. But what we're really thinking about at its heart of this session, the reason I love this session at its heart is I am on a mission to help people start treating database code like real code. It is real code. We need to treat it like real code and use tools like source control. Using source control helps us have accountability. I mean, even just to ourselves. So like, oh, who is the one who did this, a year ago, and why is this like that? Look at the versioning history. Oh, it was me. Right? It's happened to me many times. But it really helps us also collaborate together. So it helps us say, hey, can you review this code in really efficient ways without having to script something out of the database at the last minute, attach it to an email, put it in a file share, do all that weird stuff. We should have a way that version control enables us to get quality code reviews. And it should help us make our code better. Application developers for years have had things like automated builds, automated tests, automated deployments. This not only helps you deliver value to customers faster, it helps you do it without taking the whole system down, right? And that's what we want. We don't want to be up all night. We want to be able to deploy in ways where we're like, yeah, we have automated validation. Yeah, people are validating too. People are still important, but the machines should help us. And versioning, having your code in source control, is really foundational to being able to use automation to improve code quality. So this is going to help us. This matters in a lot of different ways. There's a lot of value attached to this. Here's a little bit of where we're going in this session. And as you'll see, I have a corgi puppy at home. Her name is Freya. She is 12 weeks old. So we'll be talking about why is database code special, like a baby corgi? I'll be covering 3 major branching strategies. And they're out there, if you search on how do I do branching, this session's probably kind of badly named, to be honest, because the session is about like best practices for doing this with database code. Those don't really exist if you search for them. We're kind of making them as we go. This session is about let's make some best practices for this, because when you do searching on branching strategies, you'll find that there are plenty of branching strategies for application code. But nobody talks about what happens when there's data involved. So that's where the fit notes come in. We're going to say, what is this pattern? And then, OK, if we're working with data, especially data we don't want to lose, how do we need to adapt this pattern to make it work for us? And then we'll figure out some guidelines, real brief at the end, to fit your branching strategy. Sound good? All right. One person's leaving. I understand. He's like, I'm not leaving. I didn't mean to shame you into staying. I'm so sorry. They're just tweeting, Kendra is shaming audience members into staying in the room. Maybe people are allergic to dogs. I understand. So why is database code special? Well, one thing that's special about database code is that it's not in source control anywhere. At our company, we do a survey every year and ask, different things about what are your practices. And people respond to this survey saying, about 50% of respondents say that their database code is all in source control. 50%. How many of you think that 50% is way high and that actually far fewer databases have their code in source control? Yeah. Sometimes when we fill out surveys, we might be a little optimistic about our world. Like, oh, it's total. I'm sure it's in source somewhere. Surely it is, right? So the database code is special. And one of the reasons that I think that a lot of it isn't in source is that people have great intentions. So that, OK, we should do this. We should put this database code in source. If I have that thought and I start looking around, I am immediately met with a decision. Like, oh, how do I get my database code into source? What do I do? And what I find is that there's not just one way to do this. There's a bunch of people who are saying, oh, you should do it this way. And then there's a bunch of other people who are saying, oh, you should do it this way. And there's these two major approaches. And so I'm like, well, which one's right for me? And then there's all these different tools associated with the different ways. So I met with a fork in the road, and then there's all these different tools involved, each on one side or the other. So people get stuck, right? Oh, this seems really hard. I'm not going to do this. So if there's one thing you remember from today's session, remember the corgis. But if there's a second thing you remember from today's session, the second thing is actually just pick a way. If you're not sure, just pick a way, get it into source. You can always change it later. But the first step is just to pick something and go. The only bad choice is to be like, I'll do that later. Just do it. And don't worry about doing all your automation at first. Just take that first step, get it into source. And we're going to talk about how to do that today. The other reason that databases are special, though, is that it is different than application code in a very important way. And this is, we need a place to store the data that we're working on with it. If I am writing a query, and the query has a where clause or joins in it, and I run the query against a database that's just the schema, and it has no data, it returns no rows. And I'm like, well, I have no way to kind of validate, did I filter out the appropriate rows? I don't know. It's always going to return just 0 rows, right? So we need a place to actually be able to run queries again. It is different than app code. In a dev environment, I have to have something to interact with. And so what people have been doing for many, many years is using a shared development database. If I work on a team with 5 people or 10 people, the way people are doing this is we each are checking our code into source control when we get there. But even while we're doing that, we're testing and developing that code against a shared database. So how many folks currently use a shared database? Just about, yeah, this keeps happening. There is a link on this page to an article written by a fellow named Troy Hunt. Troy Hunt, and any Troy Hunt fans, he wrote the website haveyoubeenpwned.com, where you can check for if your email address has been in data breaches. He's a Microsoft MVP. He's an amazing speaker. He's handsome. He's wealthy. He has photos of himself on jet skis. I kind of hate the guy, but he's amazing, too. And that's actually, I think, what he's going for. But he's super smart. And in 2011, he wrote this amazing post. Again, he's kind of perfect. But it's about the unnecessary evil of shared development databases. And he points out a lot of stuff in there about problems, like the last writer wins problem. So if I'm using a shared database development with this gentleman in the front row, and we're collaborating, we're working together, and I make a change to a stored procedure in the development database, and maybe it is one of those databases, right, where like we've got that one procedure that we have to touch all the time. And then you make a change to that stored procedure, and you need to do it, right? You're just getting your job done. But he has overwritten the one copy we have in that database. And if I haven't had the timing to commit it into source control yet, I might actually check his changes into source control, or I might check mine in, and then they're overwritten in the data. Just things get real weird. But my biggest problem, actually, with the shared development database is that it limits experimentation. It limits my ability to learn. It makes your code worse because I need to be conscious of my teammates. If I'm using a shared development database, I mean, I'm pretty comfortable looking dumb, but I'm going to be nervous about, am I going to do something in there that's really dumb and messes everybody up? You know, oh, I'd like to change that data in the table to see if my query changes, but I'm afraid to do it because it might mess everybody up. Oh, I'd like to see maybe if a different coding pattern would work, but I can't really because I'd have to change too many things, and there's no way to reset it. So this is the huge problem. So the important thing to know about this is, we're talking about branching in code today. Using a branch in source control gives you a certain level of isolation. If I'm committing things to a feature branch I'm working in, I'm committing them in source control to my own little workspace where it won't bother anybody. However, if I'm using a shared development database, I'm sort of undermining that whole thing, because everything I'm doing is in a shared development database where it can impact anyone. It's like everyone is using the same feature branch, which you're going to see it doesn't really make sense. That's not what we want. So I know that some of you might be thinking, that sounds nice, Kendra, but I have a large database, and not everyone can have a copy of it. It's real talk. Like, it's not always easy. There's tooling you can buy that can help with this. But even if you can't buy the tooling, I personally would rather work, like if I have a 2 terabyte production database, I would rather work on a small development database than on a 2 terabyte development database. Because if I have even if it's shared, I don't care actually. Even if I have a 2 terabyte development database and I create what happens if I create this index? How long am I going to be waiting for the index to create if it's on one of the larger tables in there? I definitely want a production-like database in some of my environments, in pre-production environment, in QA environment, and things like that. But I want to work fast in development when I'm working in some of the branches we're going to talk about today. So think about, when you're thinking about this, OK, maybe I can't have the perfect world. Maybe I can have a curated data set that's viable for development that helps me do this. I think that's better than having a shared development database where I'm afraid to make changes, or even if I'm not afraid, I might just mess you up all the time. Right? So that's worth thinking about, as we're mostly going to be talking about the branching, but you'll see that I'm making copies of databases, and it's worth thinking about how can I get to a place where I can do that, at least in some parts of my development lifecycle, right? Because we might want production-like stuff later. We do want production-like stuff later on. We'll be talking about how to get the code into source before we kind of go into the branching stuff. And there are 2 main approaches to this. And they spread across databases. This isn't all just things people think about in Microsoft's data platform, for instance. There's something called the state approach we're going to look at first. And how many folks use SSDT in the room? Microsoft SSDT, I got some folks. Yeah. So this is an example of the state approach. It is actually a hybrid tool. It has a little mix in there. But it records the state of the database. And since SSDT is included in Visual Studio, this approach is quite popular in the Microsoft data platform. Now, in my experience, in working with people who work in other platforms, now, we're first going to look at the state approach. The second approach we're going to look at is called the migrations approach. And in my experience, I'm working on getting the numbers behind this, people in non-Microsoft platforms very, very commonly use migrations. They sometimes use state. So I have found that state is uniquely popular in the Microsoft data platform, and I believe that is because it's there for you to use in Visual Studio. What is the state approach? All right, so this little line going across the screen just represents time passing. And hey, it's our first branch. We have a branch named master. So we've got a source control timeline here, and the blue dot just represents a commit. What we're storing in source control in this state approach is all of the object definitions in our database. Everything in the database, unless we have some way we filtered it out, is stored its actual definition. So when you look at the code in source control, what you see is, OK, it's create table. This is the post table. We have all of the columns with everything about them. Their data types, whether they're null, any constraints on the table, any indexes on the table, everything about this table except for the data in the table. Just the schema of it is stored in source control, along with the schema of every other object in the database. In this state model, when we go to deploy the code, right, I can't always just deploy create table post because maybe the post table already exists. So in this example, let's say what we've actually done in our development environment is we have added in a new column. We've added in the modified date column in this table. So what we're actually doing is just adding one column to an existing table. But what's checked into source is actually just the full definition of the table. When we go to deploy it, whatever tooling we're using, maybe we wrote it ourselves. Some people actually do write their own state-based tooling themselves. Maybe we're buying it from a vendor. But that tooling will look at will point it and say, we want to deploy to that thing. And the tooling will look at that thing. It'll script out all the definitions of all the objects in that thing, and it will compare them to what we are pointing it at in source control and figure out, OK, like Google Maps, Waze, or anyone use Apple Maps? No hands. Someone was scratching his head, and I thought there was an Apple Maps use. No one likes Apple Maps. It will figure out the automate. It'll just say, oh, OK, I looked at the definition in source, and it had an extra column. That column isn't in the target database, so I will automatically generate the code to get you from where the state you are in the target database to the state you're in source. And if I've made a bunch of changes, it will generate scripts for a bunch of them. When I actually go and deploy, a lot of the tooling is actually, like I said, SSDT is a hybrid tool. A lot of the tooling is a hybrid tool. You'll have a pre-deployment script at the beginning. And this is where the hybrid gets in, because the pre-deployment script, a lot of tools have this. It gives you a chance to actually write the SQL that goes in there. It's not auto-generated. So you might do something in there like, oh, I'm going to check. I know that some of my code later in the thing, it creates the table on a file group. So maybe I'm going to check, does the database have a file group with this name? And if not, I'm going to create it. But it has to be rerunnable code. We have to have that guard clause to check there. In the middle, it'll run all the auto-generated stuff. And then we have a post-deployment script generally that we can run at the end. So let's take a look at what this looks like in an example. And this is an animated GIF, just to minimize the screen switching I have to do. So we're looking at the Northwind sample database. This is an oldie but goodie with Microsoft. And I recommend, they're still online. They have the code in GitHub now. I recommend using Northwind and pubs because the code in them is awful. It's just terrible. But when you're learning something, right, it's rich for things you can improve. And it's also quite simple. They hadn't done that thing they do later with AdventureWorks where they stuff every feature in the thing in there. So I like using Northwind and pubs. It's a nice thing when you just want to kick the tires of something. What we've got here is a repo in Azure DevOps. It's Azure DevOps Services. If you want to play around with some of the stuff I'm showing today, there is a free tier of Azure DevOps Services. You can do all of this stuff with the automation bits I'm going to show you. You can do them all with Octopus Deploy. You can do them with other things. But there is a lovely free tier of Azure DevOps Services, so it makes it real nice to just learn. And this is an SSDT repo. If you look at SQL Source Control, which is a different product made by Redgate, you'll notice it actually looks quite similar. So a lot of state repos are going to do similar things like this, where we have a tables folder. And then we have in there, notice that this is the entire definition for the customer demo table. See, it's great. And then here is the employees table. And notice that we do have all of those constraints on it, and we've got an index at the bottom, right? So this is everything in the database. We've got tables, we've got views, and that is what our repo looks like. So the convenient thing about a repo like this is at any given time, if you're like, I want to know what is the, what does this table look like? I can find exactly what that table looks like, and I can very easily compare this to a real database. I don't have to look at multiple files to figure out what an object definition is. This is the project file that is maintained. Often these solutions will, when you're adding things to them, they'll have a project file that lists, like, here's all the objects in the schema and whatnot. But there are some sneaky issues with state. One of them that I actually don't have on this slide, but I should make sure to mention, is when you do that diff and you deploy at the end, like, let's say I'm deploying something where I did just make a change in the post table. The only change I made was to add one column to posts. When I go and deploy to the target with state, it's gonna make everything look like my source code, not just the posts table. So if someone has been in production and they weren't going through source control and they were like, oh, I need to create this index to solve this problem, and it's on the users table or whatever, state is going to say, no, everything needs to be in the state that matches source control. It is going to eliminate all the drift. So that is an important thing to know, is it doesn't just deploy what you change, it deploys the state of all the objects you are source controlling. It's good. It's not necessarily good or bad. It's just an important thing to know. So that makes life kind of fun, because you really have to be careful if anything is not moving through source control before it goes to production. You could wipe something out, and maybe you should, and maybe you shouldn't. You just need to generate that script of what are you going to do, and someone needs to review that. Other things you might want to look at in that script. Sometimes if you do renames of items, the tooling, depending on what tooling you're using, it might see that rename as a drop and create of the column or of the table. And then what about modifying data? We check in the schema of the tables, not the data, right? Because, I guess if we checked in all the data, we would never have to do backups, but it just wouldn't work. Like, it wouldn't stay up to date. And there are actually ways you can store little tables. Many tooling will allow you to store, like, if you've got a countries list or a small reference table, this is often referred to as static data that you would store in source control. And because users are not updating that data, right? This is data that you control that helps your other queries work. So you can keep those in source control. But what if we have a 4 gig table, and we messed something up and the data isn't right? We need to run some update and delete statements. Where does that go in a state-based model? Well, it's a little awkward, because the pre and post scripts run every single time. Do I want to put my data modification script in a pre-script? Well, I could. I just would need to put it in for one deployment. It's committed to source, and then I'd have to take it out before the next deployment. That's kind of weird. So you have to kind of do workarounds for these and figure out, either are we going to run this out of band of the state model? Are we just going to run these through a different pipeline? Or are we going to do the pre and post thing? You just got to figure out how you want to do it. Because what we're really controlling is the schema of the objects and then these small static data objects. The other thing that happens with state, for any of you using SSDT, do any of you have really, really long, complicated pre and post scripts in the room? Anyone have that? We've got a couple hands here. We've got a couple hands. It can happen, like, if you start getting into, we have to work around this and that, sometimes you just forget to take it out of the pre and post script. Sometimes, bless you, sometimes it just gets complex. So that's not a terrible thing. You just have to be willing to manage it. All right, that's the state approach. That state approach, very valid way to get code into source control, works super well for some teams. Some teams prefer, however, a migrations approach. I learned using a migrations approach long, long ago, before anyone sold tooling for database code or provided it in any tooling. We built our own tooling to enable us to store and deploy code. We were using Visual Source Safe. It was the best thing we had at the time. But we had tools that we built to work with it. So I'm going to show you today a tool called Flyway. It is a free tool. It is an open source tool. Redgate actually acquired that. So I try not to push products. I'm not trying to sell you anything, but yes, I do work for a company that acquired this. I wanted to show you DBUp today originally, but it took me forever to install. It might be me, but Flyway is really easy to get started with. So it's free. It's community open source. I think it's really cool. And even if you're happy with SSDT, there might be times when you're like, oh, we actually want a Flyway pipeline to handle certain things. So I think that's why I chose to demo it today. I was like, yeah, I think this can be useful. And I think it's also really a good tool for learning. And it's totally free for everyone. But there are other tools in different things, too. And you may notice that I've got Flyway on both of these platforms, or both of these sites. Migration tools often work for many different platforms. And that's because migration tools don't inherently have to understand the database as much. For that state tooling, right, it had to know, how do I do a diff between these things? How do I generate the SQL? It has to know how to script out all the objects. For a migrations tooling, as you'll see, it has less responsibilities. So it's easier for people to write a tool that's like, oh, sure, I can talk to Postgres. Maybe I can talk to MongoDB. Heck, why not talk to Amazon Aurora, right? It's just easier because the tool doesn't inherently have to be as smart. But of course, someone's going to have to be smart, and that's going to be the user. In this approach, we don't store the object definitions in source control. In this approach, we store the migration scripts in source control. And I just haven't explained anything there. I'm like, migrations run migrations, right? That explains nothing. I got really, the wording on migrations actually I find really uncomfortable because I still am like, do you mean a server migration? Like, what are we talking about? What we're actually talking about as migration is a simple change script. It is some sort of T-SQL statement in our case. There are tools that will run Java commands as migrations too. So this is across different platforms. Things use different things. We could, of course, have multiple commands in this file. This one is simply, but what we're storing in source itself is the alter table add column command. Except in the alter table add column, we do not use the word column in the command. Like, I always feel like the T-SQL looks wrong because you just say add, and then the name comes after. But then when you drop, this is just a private rant. I'm sorry to bring you in on this. When you drop the column, you have to say drop column. It's just, see, so you have to know a little more when you're doing this, or you have to be willing to test your code and look it up. Because maybe some of the tooling does help you author this. There are hybrid tools that will help you author this. But the point of the migration script is that you get to control this. So that if you want to say, oh, I'm going to alter the table and add the column, and then after that, I'm going to run a command that inserts some rows. It's real easy to do that because we can put whatever we want in these migration scripts. We have a lot more creative freedom here because a migration can be anything you want it to be as long as it's going to work when you deploy it to a target. When we deploy with a migration tool, it doesn't have to do a diff, right? We have given it the exact commands that it's going to run. Its job on the deployment is simply to check what migration scripts have already been run. I am not going to run those again. And I will run all the new migrations and bring it up to date with what you have in version control. Migration scripts are only ever run once, but many tools also have sort of a hybrid thing here, although this is more just like an extra feature. So some tools, Flyway does not have this, I don't think, but some tools have the ability to do the pre and post-deployment scripts in here too, where you can say, hey, if that file group doesn't exist, create the file group, that kind of thing, just for convenience. Because essentially, those are just a type of rerunnable migration there. Here's what a migrations-based repo looks like, because there is something I haven't covered. If you're sort of used to working with migrations, you're like, she skipped a step for existing databases. If you have an existing database and you get started with the migrations approach, you might want to be, in fact, you should want to, you always want to, when you're getting your code into source control, you want to be able to deploy that code to an empty database as well. Yes, we do want to go to an existing database. If it exists already, we want to go to a target database and bring it up to date. But we also want to be able to say, hey, let's run all of our code against an empty database and make sure it's all valid. Essentially a form of building the code. We're going to make sure all our code in source is valid. So for an existing database, for the migration script, we need to create what is called by many of these tools a baseline script. And a baseline script, we just script out the state of the database. So in this case, I went into the SQL Server Management Studio tool that scripts out all the existing objects in the Northwind database. And you'll see on the left, this is the way Flyway versions Northwind. There's a naming convention for files. This is common. Different migration tools will have a different naming convention. And the naming convention sometimes will influence the order. Sometimes there's a little thing in the header of the file that influences the order. You just get to know your tool. How does it determine the order these are going to be run in? For Flyway, it's very much about just the order of those numbers. So in this baseline script here, which it says, we name it baseversion.sql, it is, when I started developing this, it is how everything's scripted out as a create statement there. These are the migrations after the baseline. I have individual migrations. So this is alter table, add a column, and then I think I've got a couple more in here. But you can, the advice generally, people say keep these very small, keep them very simple, because you can run multiple migrations in a deployment, of course. Now, one of the things that is a little tricky about this, I'll let it play through to a certain point again, is with these individual migrations, if I'm looking at that and all it's got in an individual migration is alter table add column, how do I know what the whole table definition is? Like, oh, OK, do I have to go to the baseline script and then find every single alter I've run for it, right? Because just looking here, just looking at this, what is the if I'm curious, what is the customers table as defined in source code? It's not really here, is it? Some tools are hybrid tools for this reason. So some tools are a more migrations-first approach, and they let you store the migrations, and then they also automatically update state in the background for you so that they are doing the second, so that you can do things like compare easily that branch with the database and so on. I even met someone in Denver at a SQL Saturday who was manually doing that. His approach, their team, they actually script out and maintain and check in the state. They built all their own tooling. That sounds like work to me. I would rather not do that myself. This, there is a way, of course, we can figure out what is the state of the table. We could deploy all our code to an empty database and just look at that database. And deploying to an empty database should be really fast, right? Because we don't have any data to move around. So it's not like it's impossible. It's just mildly inconvenient if you don't have a hybrid tool, right? But we can find a way. It's just something to be aware of. Like, it is awfully nice to know, oh, OK, what is the state of that? So you, in a simple migrations approach like we'll be taking, you might have to actually deploy the code to a database to easily just say, what does that table actually look like at this point in source control? The other thing about migrations that can get tricky is we're talking about branching today. And when we are using something like a feature branch, which you'll see in the demo, and then we're going to merge back into another branch, because it's our migration scripts, their names were things like 002 underscore whatever words I put in there, .sql. When you merge files in source control, the way it detects conflicts, the way it detects, hey, are you changing something someone else has changed, is it looks for files with the same name and then uses that to do the comparison. But we're all going to be naming our migration scripts different things. So how would I know if I'm merging in? I'm very unlikely to get an automated conflict saying, hey, someone else touched the post table, or someone else touched this stored procedure. You might overwrite it. Because I've got those numbers in there. So if I'm using a non-hybrid migration tool, when I do this with the branching, I'll show you this when it happens. When I do this with the merging, I'm going to have to look carefully and say, OK, has anyone else been touching this? Am I going to accidentally overwrite the changes of anyone who's done stuff since when I created my branch? So state tools just take care of that by default, or a hybrid tool will take care of that by default. But I do love migration tools. I do absolutely love migration tools. Now, both of these approaches have rollback problems. And anyone like rollbacks? Someone scratched their head again, and I was like, oh, you don't like rollbacks. You don't like rollbacks. Nobody likes rollbacks in any context. How do we roll back if we modified data, right? Especially if data's been changing since I modified data. How do I write a script for that? Oh, I changed this data, and now it's changed again. What do I do? Even if I just add a new column to a table, unless I figure out a problem before users have actually done anything, is it OK to just drop that column if now there's data in it? It's going to vary a lot. How would a tool know? If you've dropped something or truncated, right, just putting the schema back maybe is OK sometimes, usually not. And then finally, even just some things of, oh, I did a thing against a big table. The time taken to undo it is sometimes just unacceptable to the business. The other thing about especially the state approach, right? For the state approach, I am capturing the state of all these objects. If I do, it's a lot of folks who do the state approach, they roll a bunch of changes, and they're not broken into those individual migration scripts. So do I want to undo all of them and go back to the previous commit? It just gets sticky. So we still need people. And when something goes wrong and we have to actually undo something, we really still need people to be figuring out what is the right way to undo this. There is in migrations, in many migration tools, there's something called up scripts and down scripts. Flyway actually has this. I'm just showing you the up scripts today. But up is your roll forward. Down is roll back. And so you can pre-write, OK, what will I do to roll back this individual change? But these things still present a lot of problems. Because should my response just be to drop the column, or should I do something else? But I do like the fact that you can write a down script, which is whatever you want in migrations approach in some tools. So these are just a summary. When you're thinking about these two approaches, with state, it is absolutely easier to identify merge conflicts and to compare source to other things. I do think branching strategies are just going to be easier with a state approach. That is part of the virtue of it. Things get tricky when it's the wipes out drift. Things like, oh, we have three deployments going out, and now we need to change the order that we were planning to do them in. Gets really messy with state. For migrations, on the other hand, yeah, branching and merge conflicts are harder to detect. But this fact that it allows drift when you want it, and the fact that you really can control the commands executed, I mean, that's a huge benefit for databases that have high uptime requirements. So, I mean, each approach has a virtue. And this is why I said at the beginning, it can be hard to choose. But just make a choice. Just get started. Just go. Because neither of these is a bad choice. That is the important thing. Just get your stuff going. So now let's talk about how fitting these database, the ways we manage database code, fitting this into how do we do branching and merging for this. So we're going to look at three major branching strategies, which really weren't designed for databases, and talk about how they fit with databases. Anyone use Git Flow already? Anyone? Got a couple of people. It has long staying power, right? When people start using this somewhere, it has long staying power. This is why I'm talking about this one, is that sometimes when you begin talking with others in your organization, they're using this, they have used this for a long time, and they're like, yeah, we just think we should use this. And that's fine. Git Flow has two long-lived branches. In Git, you may hear me say the word trunk. Trunk and master, I use the words interchangeably. The mainline branch, I often call master, but sometimes I'll fall back and call it trunk. And in Git Flow, that is generally meant to be production code. I'll show you a little diagram in a sec. There's a develop branch, too. And here's how they look. Let's just look at the diagram, right? So develop lives for a long time. It's not like we're going to drop develop at some point or merge it. We may merge between it and other branches, but it's going to stay around. We do a lot of work in develop, and we may use these feature branches off there. We may branch off develop into a feature branch, do some work in there, and then merge back into develop. At some point when we're ready to release, we'll use a release branch there. And if we make changes in the release branch, we have to make sure those get back into develop as well as into master. Because we want master to represent deployable production code. People have started moving away from this, or not started. People have moved away from this by and large. It's still got its fans who've been doing it for a long time. But the big criticisms of this is, wow, OK, maintaining develop and master, we got a lot of garbage in develop. Well, how did that happen? It's extra work to maintain both of them for a long period. So there's good pros to this. When people are really familiar with it, they can do great things. It has wonderful, thorough documentation online with questions about, oh, how do I do this hotfix? How do I do that? But it does have more complexity than the other models we're going to look at. So I don't generally recommend people to start with this. But if they want to use it for organizational reasons, I don't have anything against it, right? You just got to you got extra stuff to clean up. You got to clean up develop. You got to make sure everything in develop actually is fully tested. Well, what do people agree on? People who use this as well as the other ones we're going to talk about, when you're thinking about these, especially the ones we're going to look at now, when you're seeing the word feature branch, think about a feature branch that doesn't stick around forever. Generally, we want to work towards, as much as we can when we're developing changes, developing them in small units that are very, very testable. Even if we're not going to release this feature right away, it will benefit us to, OK, I'm going to work on this in a small chunk. I'm going to get feedback on it. I'm going to do some testing on it. And then I'm going to merge it back into a place where other people are working so that they have access to that code. That if we all do that, if we all can work in short chunks and be merging the changes back in from these branches we're working in regularly, it means that by the time we get ready to deploy, whether that is every day, every week, every month, or every quarter, we've already been merging all along, and we don't have, like, if we do long-lived feature branches that we never merge back in until the end, at the time we merge back in, it's like, oh, I made 17 changes to that procedure, and you made 4, and Jody made 3, and then we all have to sort it out at the end. So however frequently you deploy, you still want to have this goal of, I want to work in a short chunk and have a strategy where I can merge this in with other code, get feedback, and make sure it looks good, make sure other people are aware of my changes on a very regular basis. So we work in a feature branch, and then we collaborate before we merge. So I've branched off, one person has branched off a feature here. They're doing work in there. The next person branches off. The second feature branch, when it merges back in there, right, it's going to have to pick up. Were there, did anyone change any of that stuff? Do we want their changes? Do we want my changes? Do we want both? Maybe we did change different things, though, right? So maybe we don't have to figure that out. But it just simplifies it if these are shorter lived. And most everyone agrees on that, because people hate merge conflicts. If you search for, like, meme merge conflict, you'll find, like, all these Braveheart photos of, like, merge conflict. So keeping these short can help. If you can't keep your own branch short, like if, this is taking forever, you do want this to be a general practice, because then you can still refresh your branch from master and at least be pulling in the changes everybody else has been making so that you're aware of what else has been going on. So even if you have some feature branches that have to stick around longer, the general practice will help you not get too out of touch with reality. And we want to stay in touch with reality. My favorite way with Git to stay in touch with reality is pull requests. Any pull request fans out there? Yeah. These are good. They're a way that you can say, hey, can you give me some feedback on my code? And there's all these cool automation points that you can do with pull requests as well. You're going to see some of those. We can also, we can say, OK, you got to do a pull request before you merge code in. And a branching strategy that made pull requests very, very popular is called GitHub Flow. GitHub as in GitHub, right? So it's like GitHub Flow, but GitHub Flow. Because I don't really know how GitHub got its name. The main thing with master and GitHub Flow is they do want the code in master to be deployable. And they like to deploy very, very frequently. So let's take a look at how this diagram works. This diagram would be better if it had some squirrels on it. I'll explain why. Squirrels are the symbol of deployments, right? So I guess they just take things around. I learned about this from actually a fellow at Microsoft, Edmund. I should have his name in the notes there. I don't. I'll publish a post after and put his name in it and give him credit. Because he used to work at GitHub. Now he works, I believe, currently in the Azure DevOps team at Microsoft. But he explains how they release at GitHub and why they can't do that in his team. With GitHub Flow, we've got these feature branches coming in. Notice we don't have any, there's no long-live develop. We just have master. Master is deployable code. And then we've got feature branches. We don't have release branches either, right? We've just got master. And then there's nothing missing from this diagram. The only thing missing is the squirrel. What we do is we work in these feature branches, and the purple dot is a pull request. And at the point of, they do make a point to say the pull request is really initiating communication, saying, hey, I'm getting ready to deploy this code maybe, but also I want someone to look at this and tell me about it. And what they actually do at GitHub when it looks like the reviewers look, yeah, this looks good. What they actually do is they have automation around this that as their pull request is going in, they lock down the master branch so that nobody else can go in at this point, and they deploy the code from the pull request to either production or some sample of production, some canary set of servers. So nobody else can go live while we're doing this. We're actually deploying the code from our pull request to production, and then they wait and see how it goes. They're like, oh, did we break anything? If we broke anything, they're like, we're not actually going to finish that merge. We are going to redeploy master to production. This is all the squirrel doing this, right? The squirrel, like very busy squirrel. We're going to redeploy master, and that pull request is not going to happen. This would be great to do with databases, except, you know that thing I mentioned about the rollbacks? Yeah, this is really hard to do with databases. There may be some cases where you have a database that you can do this with, but maybe not, right? We need to adapt this, really, to do this with databases. So this won't fit for most of us, but some people do this. This is not easy mode, right? Because what we're doing here, there is still some squirrel activity that we're going to talk about in this picture. The squirrel's just doing things differently. So this is an example of, anyone have a microservices initiative at work? Yeah, so with microservices, they are hard. Microservices are not easy. But they do make certain things easier for database people. Like we're shifting the hardness to the people who have to actually figure out how to move the data around, which maybe is us too. But part of the thing about microservices is, a big part of the theory is, you have very simple data stores, and the data store just has one user. So for every database, you don't have cross-database joins. You don't got no link servers. You don't even have like multiple apps using the database. You're like, if we touch this thing, there is one consumer of it. So it's very testable for database changes. So for a microservices model where we have very limited dependencies for the database, you can make changes to the database and then just make sure all the APIs, everything that the service is talking to, is healthy. And I said microservices isn't easy. I mean, people have hopefully invested a lot in being able to test things at the application level. This means that this pipeline can be a very good fit, especially in a greenfield project, where as soon as we're doing a pull request, we're getting quality feedback. And in the pull request, instead of deploying to production, we do something like, OK, I'm going to automatically create an environment, a fresh new testing environment. I'm going to deploy everything to it. And then my code reviewer has something very production-like to actually work with before we ever merge it in. So instead of deploying to production, we make something production-like. And then also we add in automated tests and things like that before we actually deploy to production. This does mean that we have to be comfortable with frequently deploying throughout the day, throughout the week, because we don't want this pipeline to get too backed up. We might still have a gate at the end where someone actually presses a button before it goes to production or something like that. That's fine, but we don't want there to be a big backlog in this pipeline. This is a good thing for some databases, but if you've got a legacy database, if you've got anything with complex dependencies, or even if you're just starting, going from deploying once a month to deploying on demand is like, well, OK, maybe we need something in the middle, right? Maybe we should take a smaller step. So this might be someplace you want to go. You might not go there right away. I have a dumb question. Do we end at 45 past? Yes? Do we end at half past? 45. Yeah. I usually write it down on a piece of paper right here at the speaker tip. Write down when you, I'm not following good speaker tips. Thank you for your help. We end at 45 past. I've been having so much fun. I'm like, How much time is that? I know what time it is. So okay, we're right on time, actually. And now let's do some fun stuff. Let's have a demo. I shouldn't sing, especially in the morning. But this is some of my favorite stuff. All right, I am in Azure Data Studio. You've been at Past Summit all week, so you know what Azure Data Studio is by now, right? Like, we've been talking, everybody up here is like, Azure Data Studio, it's got these cool stuff in it. We like it. So I'm connected to just a local, yep, it is showing up there. It's good. A local development SQL Server instance. And I have this database named Northwind Deploy. I have a Jupyter Notebook, by the way, that I'll upload with the slides to the site that kind of outlines the commands I'm going to show you here. So you do not have to like remember all the commands. What I have here is just a PowerShell terminal that I am in. I have a Git repo set up. It's basically the same thing I showed you that has the baseline script and then has a few migrations in it. And I'm in that database here. So I can say git status. And I am in the master branch right now. My branch, I don't have anything I've done in there right now. Let's go ahead and pull, just to make sure. I'm pretty sure I pulled things down. So I was maybe running my demo earlier today and did some changes. So now I know I have, from my central repo, Git has a central repo, and then I have my version of the repo. So you'll see me pull from the central repo and then also push to it. Let's talk about Flyway a little bit at first. We're going to make a change, and then we are going to use a feature branch. But how do I even know, how do I even make the change? So let's take just a quick tour of Flyway. If I do Flyway info, Flyway just has a few commands I'm going to use today. One of them is info. And I like to use info just to say, hey, are you working? There's a little configuration file where I told it, here's my development SQL Server instance. And you can't, I have this set up with SQL Auth. You can use Windows Auth. I'm using Northwind Deploy. It's my development instance. And it prints out this nice little table that says, here is you saw the base version earlier, right? That's my base version. And then in this pipeline, I've run these migrations. And see, I can actually name them in different ways. So I've got 2, 3, 4, and then I decided to do 402, 403. You can use whatever you like for that. And it tells me, oh, these have all been successfully deployed to Northwind Deploy. So let's go ahead and clean it out. Be very careful with clean, because clean is a little nuclear. Clean, really clean, it's going to drop everything, not everything in the database. It's going to clean the schema of the database. Because it's cross-platform and it talks to other databases, sometimes they use the word schema slightly different. It just dropped everything in my database. So only clean when you know you're connected to something that's OK to clean. Now if I do Flyway info, it says, hey, I looked at that database, and you haven't deployed any of these things to it, right? Because it cleaned everything out. Now I'm going to go ahead, and the way we deploy is we say Flyway, and then we say migrate. And it will go look at the target database and say, I've got all these scripts. Which ones have been run before, which haven't been run? I'm going to go ahead and run them. And it ran them. It brought it up to date. My migrations are done. So I love the simplicity of this approach, right? Like, I know where I stand. This is what I got. I can look in every script, see exactly what it does. So if I now do Flyway info, right, now they're all successful again. So let's make a change. I'm going to make a change in a feature branch. So I'm going to do git checkout B, and I'm going to name it features, and let's say, let's add the TikTok column. I don't think I've done that in here. We'll see what we name it. We'll see what we do. I like the Git command line. Any Git command line fans? Yeah. So for everybody who didn't raise their hand, if you're like, isn't learning the command line harder than learning with a graphical tool? In the case of Git, one of the things I really like about it is I actually think learning with the command line is easier than learning with a graphic tool. I find it less confusing, and I think it's really helpful. So I'm going to go ahead and check this branch out. I'll show you in a second. Actually, let's make an error. So what I've done is I've said checkout. I want to create a new branch with this name. Let's say I just forgot to. Now I've just erased my command. So we'll do git checkout. We'll forget to do the B, and we'll name it features and then TikTok. Right? And it's like, oh, yeah, this path doesn't exist. OK, I need to create it. And I can either create it with a new git branch command, or I can be like, oh, but nothing's harmed. Everything's fine. I feel like Git is very nice because everything's fine. So now it says, OK, yes, I checked this out. In other words, I switched to the branch. And since I did -b, it was able to create the branch. Right? So I've switched to that branch. If I do git status, it says, nothing to commit. Your working tree is clean. So let's make a change that Flyway will see. I have you can open folders in Azure Data Studio, right? So I have just opened a folder containing all of my files. So we're just going to make a new one of these. And I'm actually just going to open this v2001 that was adding a column to the customers table. And I'm going to save a copy of it. So I'm just going to do save as. Been hanging out with Hamish from New Zealand. So now I want to say sweet as. But I don't really know what that means. So I hope that was OK. Anyone been to Hamish's sessions this week? Yep. I love this conference for being so international while still being so close to my home in Portland, Oregon. Oh, I need alter customers, add TikTok. There, I'm having too much fun. There we go, TikTok. Right, so I just name my file. And I should probably change my column name. Right, there we go. So I have just saved this as a new file here, right, in my directory. And now if I come here, let's close this down, make my terminal bigger. There's these new PowerShell notebooks. They just came out with PowerShell notebooks for Azure Data Studio. And I tried last night to work that into my demo, but it was super buggy. I don't think it was me. So I'm interested in playing with them more. There's a reason I'm not using them on my demo. Sometimes things would run, and sometimes they wouldn't. And I'm like, maybe I'll just stick with the terminal. I know how that goes. Now if I do git status, it's like, hey, you added a new file. If I was using a tool that did migrations based and I made a change, and I said, OK, it would also just be essentially adding files. Those files would just contain the definitions of things. So now, see what I mean about it being helpful? It's like, these are untracked files. You should use git add to do this. And then I can list the individual file names if I want. But let's say I just do git add, and I don't do anything after it. It's so nice. It's like, well, perhaps what you meant was you wanted to go ahead and add everything. A way to do that is to do git add dot. It's just such a friendly, like, thanks. It's so nice. So I'm lazy. I don't want to copy and paste the file name. I just do git add dot, right? Now the change is staged. And if I do, I'll clear this out just to make it more clear. Now if I do git status, it says these are ready to be committed. So I made a change. I used git add to stage the change. And now I can commit the change. We're still on my local repo. I'm still not, my feature branch is still local to me. So if I want someone to look at my feature branch, I need to commit the change and push it up to the central repo so that other people can then say, oh, I want to get this feature branch down. So let's go ahead and do that. We just need to commit. We'll do git commit-m important change. And I didn't put an end there, right? But then I was able to do it. It's very forgiving. Git status, and we're going to push. Right? Nothing to commit. Let's push to our central repo. I am a lazy person, so this is actually what I do every single time. I type git push. It says, you don't have an upstream branch. You created it here, and you haven't pushed yet. Perhaps you would like to use this syntax. Why, yes, I would. I never want to learn that syntax. No one does. So I copy, and then I paste, and then I push. Up in my repo, some magic is going to happen. This is Azure DevOps Services. And again, and I'm not saying other things aren't helpful. I'm sure Octopus Deploy is just as helpful. And they are just fun people, too. It says, by the way, you updated this feature branch. I know it was you, Kendra. Maybe you would like to create a pull request so someone can look at your terrible code. I would like someone to look at my, it's not too bad in this case. And I can now add reviewers. Right? I can add related work items that I have. I can even have things so that people get automatically added to this under certain conditions. But I'm going to go ahead and create my pull request because I want to show you some fun automation that I've got set up. I have a policy set up on my branch. You can easily set up these policies to say, by the way, nothing can actually merge into this branch until these things happen. So you can set up pipelines with automation in them, and they have to complete successfully before that code is allowed to merge in there. And this also helps your change reviewer. Because if I put in steps in here that validate that, hey, her code's all right, right? My change reviewer doesn't have to be like, can I deploy the script? Did she put an error in there, right? They shouldn't have to do that. That should happen for us. So let's take a look at what's running here. Right, I have a build in process. I've just called this a build because I just made this. Here's the steps it's doing. It initializes, does a checkout. And I do some things with the path. I have a private build agent set up. Essentially, although I'm running Azure DevOps services in the cloud, it is actually calling out to my laptop where I set up a private build agent. There is a page where Microsoft tells you exactly how to do this. And yes, it's all still free. And I'm using a private build agent because I want to deploy things to a SQL server on my laptop. You could also use a cloud agent. Maybe you would use that if you wanted to deploy to an Azure SQL database or to a VM in the cloud. But I want to deploy to one on my laptop, so I just use a local build agent. And so it's configuring my path. And I'm also copying down my files from my build directory. So I have a copy task that copies files down so that it has the code from my pull request. I didn't write any of this code. I just had to use a GUI. I do not, by the way. You can write your pipelines in YAML. I just use the GUI. Like YAML, if you put a tab in the wrong place, everything breaks. It's not my style, right? And then I run a Flyway clean and migrate. So I copy the source code down. I take that source code, and I have a database on the build server, and I clean that database out. Because what I want to know in this step is, does all the code deploy from scratch? So now I just say it has Flyway clean, and it points at that code I just synced down. Or no, Flyway clean doesn't need code. It's dropping things. I say Flyway clean, and then I say Flyway migrate, and I point to that code I just synced down. And now I know that all my code is valid. Hey, easy. And it's always going to be fast. But then I do a little more. I change my variable for my database, and we can see this all worked. And then I use a little tool called dbatools.io. Does anyone know those PowerShell tools? Yeah, they're the best. They're the best. If you haven't been using these, they're so cool, because in my demo, I wanted to be like, I'm going to restore a copy of the Northwind database. So if I had fancy tooling, maybe I'd be doing SAN cloning or provisioning or something like that, right? But maybe if I don't have that, maybe I'm like, well, I can at least restore a small copy of the database and prove that the code deploys to that. That's much better than using a shared database. It's not perfect, but we can do that. So I use the PowerShell command from dbatools.io. It's restore-dba database. I got my zoom here. So I use that commandlet from there. You could write your own if you wanted, but if you want to be like me and just write on other people's coattails, you could use theirs. They've written it for you. It's really easy to restore a copy of the database, and then I use Flyway to deploy to that. So the person coming to review my change, they have, let's go over to my actual SQL instance and refresh it. They have actually, and I name it with the pull request, they have actually a database in it that has, we did it on a customers table, I think, right? I always have to have, I'm like, what did I change? Right? They actually have a place where they can review the change, and it even has data in it, except for this new empty column I added. Way better than them just looking at the code. So this is, the pull request is the place where you start really communicating with other people, and you're really able to get feedback from them. And they're able, if you start using automation, to have real environments to work with, and they don't have to remember to do 18 steps. Now, there's another model called release flow. And this one, I think, is much easier for getting, like moving towards. Because we can't all just deploy on demand 5 times a day. We just can't. Like, I have done that. It's fun, but we can't always do that. So release flow, it's driving me nuts that I cannot remember this fellow's name who documented this. It's so helpful. Maybe I actually have it on the next slide. I will blog about how much I need to. Edward Thompson. Thompson without a P. It just came, right? So Edward Thompson blogged about this. He was the one who used to work at GitHub, and now he works at Microsoft. And he said, we can't do that model because we can't lock down the master branch like that. We have like a kabillion developers. And if we locked, we can't. And they were releasing every like couple months, I think, and they now release at the end of every sprint. And they are very happy with that. So they are releasing frequently, but they're releasing at the right time for them. So this is the mechanism at which they group their changes to be able to deploy them together. It's called release flow. They do advocate the heavy use of feature flags. And this is also, people with GitHub Flow do say the same thing to this. This is not unique to release flow, by the way. A lot of folks who do this say the more that you can separate the concepts of deployment from release, the better off you'll be. In other words, when you deploy a change to production, you do not want your customers to see a new feature right after. You don't want them to know you deployed it all. You don't want them to see a thing. You want that release to be incredibly boring. And then you want to have a toggle, commonly called a feature flag, where someone lights up a feature afterwards. And if it looks weird, they just turn it down. This can get complex. This isn't always the perfect thing, right? But if we can separate deployment from release, everyone's life gets better. It is additional work, but they heavily advocate for that. Here is the model that they use. And this, I think, works for a lot of database people, because you can create these release branches whenever you want. So this is very similar to Git Flow, right? There's just no long-lived develop branch. Master, in this case, represents deployable code, but not the state of production. The state of production is represented by the last release branch that was deployed to production. So we use feature branches to develop code. We merge them frequently in with pull requests to master. And master must always be deployable. There shouldn't be any broken stuff in master. And when we are ready to release, we branch off and create this release branch. Now, maybe the goal is to not have to make a lot of changes to that. Maybe there's a few things you make just for the purposes of deployment, but there's minimal. So let's take a very quick look. This is not hard to do at all. This is a quick demo of how release flow works. And there's Twitter. Hi, Twitter. I wanted to actually go to this in here. So I'm just going to go into my repo. And I need my branches. There we go. I fight with this all the time where I'm like, I wish it would just follow what my mind wants it to do and not what my hands tell it to do. So to create a release branch, I'm on the master branch here. And I'm going to go over here. There's a little dot, dot, dot. I'm going to say new branch. And I'm saying releases. And then I'm going to say 002, creating it on master. So everything in master is going to go into this release branch. And now I have automation around this. I have a build here. And I have a deployment pipeline that's going to kick off. And the magic thing is you can easily set up a trigger that says, I want to do automation every time a release branch is done. So I can do things like set up a build that validates the code, exports the code that, all of my migrations or my state, whichever I'm using as an artifact, passes it on to a release branch pipeline, which maybe creates an environment and deploy it, or maybe just deploys it to an existing QA environment. But the ability to use these folders very simply for the source of automation is really nice. And then everyone can kind of know, oh, these release branches, that's what we're working on, and that's what's going to be deployed to these other environments. So very, very, with the use of folders, very, very easy to hook into automation that helps us deploy these changes not all on demand when they're ready, but deploy them in groups. If you have like, oh, we have QA01, and then it goes to another environment, and then it goes to a fifth, GitLab Flow may be an interesting model to you. It's very similar to this, but it's very explicit about using multiple kind of release branches for different environments. And I've got a link to that at the end of the deck as well. Because there's really a lot of popular branching strategies out there, and we just didn't have time to cover them all today. But this is kind of the foundation, I think, of what gets you started. Remember that when you're using the migrations approach, you are going to have to, if you don't have a hybrid tool that's going to automatically be like, oh, someone else modified that table, you're going to have to look back carefully at what else has merged in lately. And you may have to, when creating something like a release branch, you may have to look like, oh, are these all running in the order we want? Because this is the order we merge them in. Is that the order we want to deploy in, right? You might need to think about that as well. But let's go big picture now. just wrapping up. How do we figure out how to find your fit in branching models? Well, we covered 3 of them today. If everyone you're working with uses Git Flow and they like it, go with the Git Flow, right? Just learn it, because you've got plenty of people to teach you. And then, when you're collaborating together with different things, it just becomes easier because you are using the same process. If you do have a microservices initiative, or you just have very minimal dependencies on the database, that adaptation of GitHub Flow can work very well, because you want the simplest model that really fits you. For most folks, I think release branches are going to be helpful to group changes with database code. Unless you're already deploying really frequently, I do think for many people the release flow model or the GitLab flow model, which is quite similar, are going to work well. And that is why I put all of these links at the end of the document here, so that I'll have these uploaded to the past site. I have already uploaded them, but I don't know if they're showing yet. So I'll make sure that it happens, and also put in the Jupyter notebook that has all the Flyway commands if you'd like to check out Flyway. But of course, you can use everything I showed you here with whatever tooling you want to get the code into source. Just remember, corgis are adorable, and get your database code into source control, please. Thank you so much. Thanks for coming, y'all. Have a great Friday. Please do give us evals, and thank you so much for coming.